This is a small piece of my Homelab that I take with me when I travel. It gives me a private network, local Docker services, external storage, media player, and automatic backups, and a secure connection back to my home server. And I manage to fit everything inside this portable 5-inch rack. When I travel, I usually bring quite a lot of technology with me. Cameras, SD cards, external hard drives, a laptop, a phone, sometimes a tablet. But as soon as I leave home, I lose direct access to the network and services I normally use. I also have to rely on a hotel or Airbnb Wi-Fi, which can be slow, unstable, filtered, or simply not very private. Connecting every device directly to a public network is not ideal, and using cloud services for everything becomes frustrating when the available connection is unreliable. There is also the problem of storage. When I record photos and videos during a trip, I need a quick way to copy the footage from my memory cards, create a local backup, and eventually transfer everything back to my main server at home. So I wanted to build a compact system that could provide some of my Homelab services locally, wherever I am. The solution is a portable 5-inch rack based on mini Labraks 5 inches, and the goal is not to replace my Homelab. This is more like a portable edge node, a small system that I can bring with me, connect to the available network, and use for networking, storage, local services, and backups. The network is handled by the GL.iNet AC1200 router. It can connect to the internet through hotel Wi-Fi or Ethernet, while creating a separate private network for all my devices. This means my laptop, phone, tablet, and cameras only need to know one trusted network, regardless of where I am. Inside the rack, a Raspberry Pi runs a small collection of Docker services. An external SSD provides local storage, and 20 mAh power bank adds some power continuity. Everything is contained in one compact and modular system. The first use is secure networking. The GL.iNet router creates my own private Wi-Fi network, so I do not need to connect every device directly to the public network of a hotel or Airbnb. The travel rack then uses Tailscale to connect back to my Homelab at home. This gives me access to the services running on my home server, even while I'm traveling. I can also use my home connection as a Tailscale exit node. When I enable it, my internet traffic is routed through my home network, making the connection appear as if it were coming from my house. This can be useful for privacy, for untrusted public networks, and in places where some websites or services may be filtered. This also avoids relying entirely on commercial VPN providers, whose share IP addresses can sometimes be recognized or blocked. The second use case is local entertainment. Hotel Wi-Fi is not always fast enough for reliable streaming, especially when many guests are using the same connection. For this reason, I keep a small media library on the external SSD and access it through Jellyfin. The Raspberry Pi serves the files directly over the local networks, so I can watch them from a phone, tablet, or laptop without depending on the external internet connection. The data only travels between the rack and my device. This means playback can remain stable even when the other connection is slow or temporarily unavailable. The third use case is backing up photos and videos footage while traveling. After a day of recording, I can connect an SD card reader or another USB storage device directly to the rack. The files are first copied to the external SSD. This gives me a fast local dump of the memory card without having to upload everything immediately through a slow connection. Once the files are safely stored locally, the Raspberry Pi can begin transferring them to my server at home. The upload can happen in background while enough bandwidth is available. If the connection is interrupted, the local copy remains on the SSD and the transfer can continue later. This gives me an important backup while traveling, followed by a second remote copy on my server at home. The power bank is not a replacement for a real uninterrupted power supply, but it provides useful continuity. If I need to disconnect the rack, move it to another table or switch between power sources, the system does not have to shut down immediately. It can also help during short power interruptions. This is particularly useful while the Raspberry Pi is copying files or writing data to the SSD, because suddenly removing power during those operations is never ideal. The power bank works as a small buffer between the power source and the rack. With the basic architecture decided, I could start turning the idea into a real system. I needed space for the router, the Raspberry Pi, the SSD, the power bank, and all the necessary cables. At the same time, the rack has to remain small enough to travel with, while still allowing access to the important ports and components. The modular design of the Mini Lab Racks 5 made it a good starting point. Instead of designing one complete closed enclosure, I could build the system from separate parts and modify the layout later if necessary. I started by 3D printing the structural parts on the rack and the different mounts needed to the hardware. The Raspberry Pi 5 is the main compute node of the system. It runs the Docker containers and manages the local services, storage, and backup tasks. I mounted it so that the most useful ports remain accessible from the front of the rack. This is important because I want to be able to connect storage devices, card readers, and network cables without disassembling the entire system. A compact build is only useful if it is also practical to use. The GL.iNet router sits on top of the rack, where its antennas are not blocked by the rest of the structure. It handles the connection to the external network and created a private Wi-Fi network used by the devices. The lower section of the rack provides space for the external SSD and the power bank. This keeps network, compute, storage, power together and in a compact unit. The open design also makes it easier to replace a cable, remove the SSD, or change the power bank without taking the entire rack apart. And this is a final result. It can connect securely to my server at home through Tailscale, and it can provide local media through Jellyfin. It can also quickly copy files from cameras and memory cards and then upload them to my main storage when connection is available. And because all my devices connect to the same private network, the setup remains consistent wherever I travel. This is not the most powerful server, and it is not designed to be. The goal was to build something compact, practical, and modular. A small piece of my Homelab that can travel with me and provides the services I actually need when I'm away from home. There are still several things I could improve, including the cable management, the power system, and the automated backup workflow. In particular, the power system now it's underpowered and doesn't solve the issue of rebooting when changing a cable connection. But the basic system is now complete and working. It gives me local storage, private networking, remote access, entertainment, and simple way to protect my footage while traveling. In other words, it is a Homelab that fits in my bag.